Hello everyone, welcome to my channel Easy Learning with Lakshmi Kumari. So last session we have discussed about multiples and factors, and today's session we are going to discuss about LCM and HCF, how to find by using the prime factorization. So before finding that by using the prime factorization, first of all we should know what are prime numbers. Numbers that have only two factors, 1 and the number itself, are called prime numbers. That means these numbers are divisible by only two numbers, that is 1 and the number itself. Such numbers are called prime numbers. And numbers that have more than two factors are called composite numbers. Say for example, when you take from 1 to 20, we have 2, 3, 5, 7, 11, 13, 17 and 19 are the prime numbers between 1 and 20. So when you move up to 100, you have so many prime numbers like 23, 29, 31, 37, 41, 43, 47, 53, 59 and so on up to 100, and overall right from 1 to 100 we have total 25 prime numbers. Okay, before starting into the topic LCM and HCF, first of all we should know the prime numbers, because we are going to solve the LCM and HCF by using these prime numbers only. And we have one more, like co-prime numbers. What are co-prime numbers? And in further sessions I will give you more clarification about co-prime numbers and twin prime numbers. Just here I am giving a clarification that what are co-prime numbers. And two numbers that are called co-prime if they have only one as the common factor. Here when you are finding the HCF, we are finding the common factors of the given two numbers or three numbers. When two numbers get only one as their common factor, other than one, if they are not getting any number as their common factor, such numbers are called co-prime numbers. And what are twin prime numbers? Twin prime number is a prime number that is either 2 less or 2 more than the other prime numbers. Say for example, here we got the prime numbers, list of prime numbers like 2, 3, 5, 7, 11, 13, 17 and 19 and so on. Here if you keenly observe, the difference between 3 and 9 is 2. And the difference between 5 and 7 is also 2, and 11 and 13 is 2, and 17 and 19 is also 2. So the numbers which have, the prime numbers which have the difference is 2, those prime numbers are called twin prime numbers. So here we have the some sets of prime numbers, and these are uncountable. We cannot say that this is the end of the prime numbers. 3 and 5, 5 and 7, 11 and 13, 17 and 19, 21, 29 and 31, and like so on. You have so many sets of twin prime numbers. So this is all about prime numbers. Now you got some idea what are prime numbers. Now how to write a number as the product of the prime numbers? How to write the number as the product of the prime numbers? Is it possible? Say for example 12. Can you write 12 as the product of the prime numbers? Of course we can write. 12 can be written as so many ways. Like suppose if I would like to write, I can just start with the 2 table, immediately comes in mind, because 12 is an even number. So 2 into 6. When you observe this one, 2 is a prime number whereas 6 is a composite number. And this 6 also can be written as 2 into 3. Now in the result you can see this is the product of all the prime numbers. So 2 into 2 into 3 gives 12. 2 2s are 4, 4 3s are 12. And this one is also solved by another method by using factor tree method, which is very interesting and easy to learn. This is called factor tree method, and 12 can be written as 2 into 6, or anyhow we have used 2 into 6 here. Now we will take 3 into 4 here. When you look at this 3 into 4, 3 is a prime number but 4 is not a prime number. So 4 can be written as 2 into 2. When you come to the final answer, you have to pick up all the prime numbers which you got here, 3 into 2 into 2. And always remember, don't write this as the product of 1 into that number itself. You should never write like that. So no need to write 1 into 3. So the final answer is 3 into 2 into 2. So this is an interesting method which you can follow as the factor tree method, or like you can write as the general method. So this is how you can write the number as the product of the prime numbers. I would like to go with one more example. So 24 also can be written as the product of prime numbers, which is called prime factorization by using factor tree method. You better start with a prime number as the product of the prime number, which is 2 into 12, and this 12 is not a prime number, so you can go with 2 into 6, and 6 is not a prime number, you can write as 2 into 3. Now easily you can find all the prime numbers over here, 2, 2, 2 and 3. So your final answer will be 2 into 2 into 3, which is when you multiply these all, you should get your base number. That means the beginning number what you have taken. If you get that one, then you can conclude that your answer is correct. 2 into 2 into 2 is into 3 is 24. 2 2s are 4, 4 2s are 8, 8 3s are 24. So ultimately your answer is correct. So this is how you can write the number as the product of the prime numbers by using this general method or by using the factor tree method. Now some questions you can get like find the LCM of two numbers or three numbers by using the prime factorization method, or first of all be clear with the prime factorization, then we can move on to the short division method too. So for example, there are two numbers 18 and 36. The question given is find the LCM of 18 and 36 by using prime factorization method. Then you can choose whatever the methods we have come across here, general method or factor tree method, to find the prime factorization of 18 and 36. Now I am going with general method. 18 can be written as 2 into 9, whereas 9 is not a prime number, it can be written as 3 into 3. And 36 can be written as 2 into 18, whereas 18 is not a prime number, so it can be written as 2 into 9. And again, this 9 is not a prime number, it has to be written as 3 into 3. Now coming to the part of the common ones. Now finding the LCM, 18 we got 2 into 3 into 3. And for 36 we got 2 into 2 into 3 into 3. Now find out which are same in these two. So 2, 3. These are same. So when you come here, write LCM 2 into 3, and whatever leftover numbers are there, those also multiply. 3 into 2 into 3. Now multiply all these. 2 3s are 6, 6 3s are 18, 18 2s are 36, and 36 3s are. What is 36 3s are? 18, and 3 3s are 9 plus 1, 10. 1 and 8 is the LCM. So this way you can find. And another method is called short division method. Let us try with a short division method how to find LCM. So while doing the LCM by using short division method, it's better like a keynote, write the frequent used prime numbers right from below 20 you can mention here, at least below 10 you can maintain at the corner of your notebook. 2 3 5 7 9 and 11 and so on. Generally most probably we use this one. So 18 and 36, as both are even numbers, I would like to go with two table. 2 9s are 18 and 2 18s are 36. And 9 you cannot divide with 2, so 9 carry down as it is, and 18 you can divide with 2, so 2 9s are 18. When I want to divide 9, I would like to go with 3 table. 3 3s are 9, again 3 3s are 9. So sorry, here we got one more 3 as the common, so we can cut short up to here, and your answer will be only 2 3s are 6, 6 3s are 18, 18 2s are 36. And take the common 3, 1 1. So what is LCM here? 2 into 2 into 3 into 3. So what is the LCM? 2 2s are 4, 4 3s are 12, 12 3s are 36. Whichever the method you follow, the answer is not going to change. Whether it may be a prime factorization method or the short division method. So one more example we will just try on, and the next example is 35 and 45. First we will try with the general prime factorization method. So 35 can be written as 5 into 7. As these both are ending with 5, you can find both in the 5 table. And 45 can be written as 5 into 9. 9 is not a prime number, so continue. 9 can be written as 3 into 3. Now take which are common in these two. So 35 we got 5 into 7, and for 45 we got 5 into 3 into 3. Now which are common here? Just circle it. What is common? 5 is common. So 5 into 7 into 3 into 3. Now multiply 5 7s are 35. 35 3s are. What is 35 3s are? 3 5s are 15 and 3 3s are 9 plus 1. 105. 105 into 3. 3 5s are 15 and 3 1s are 3. 315 is the LCM of 35 and 45. Let us check with the short division method too. Come on, go ahead with the short division method 35 and 45. So as these both are ending with 5 and 5, I would like to select 5 table. As these two are not even numbers, so you cannot divide with 2 table. If you can, you can try with 3 table, no problem. We will try with 3 table. So 3 table, shall we get, do we get 35? 3 tens are 30, 3 11s are 33, and 3 12s are 36. So no chance of 35. So bring 35 as it is, and 3 15s are 45. So you can go with 3 table. And now the next one, you can continue with the 3 table. As 35 you are not getting in 3 table, you can bring down 35 as it is, and 3 5s are 15. Now select 5 table. 5 7s are 35 and 5 1s are 5. When you move on, 7 you will not get in any other table because it is a prime number. So take 7 table 1 1. Now what is LCM? Very good. 3 into 3 into 5 into 7. So finally your answer is 3 3s are 9, 9 5s are 45, and 45 into 7 is 315. So the answer is not going to change in any of the cases. This is how you need to find the LCM by using the prime factorization. You can go with the prime factorization method, or you can go with the short division method. But whichever you go, you always have to remember the prime numbers in your mind. It's better to maintain the list of the prime numbers whenever you are dealing with such kind of problems. Now let us try with some HCF problems. So let us find the HCF by using the short division method as well as prime factorization method. Now I want to know the HCF of 36 and 54. Let us try with 36 and 54. So 36 can be written as 2 into 18 And as 18 is not a prime number, it can be written as 2 into 9. And here 9 is not a prime number, it can be written as 3 into 3. Now let us try 54. How can you write 54? 2 into 2 2s are for 27. 27 into 2 is a, the product gives 54, and 27 is not a prime number, so it can be written as 3 into 9, and 2 3 both are prime numbers and 9 is not a prime number, it can be written as 3 into 3. When you come into the part of finding HCF, first write 36 as the product of prime numbers, 2 into 2 into 3 into 3. Now bring 54, 2 into 3 into 3 into 3. Now here comes the option. You have to circle which are common in these two. So 2, 3 and 3. Now write HCF. 2 into 3 into 3. 2 3s are 6, 6 3s are 18. So 18 is going to be HCF. No confusion, for LCM we have multiplied even the leftover numbers too, which are not common. Those also we have multiplied. But when you come to HCF, we need to multiply only the numbers which are common. Let's try this 36 and 54 with the short division method. Before starting with the short division method to find HCF, one thing we have to remember is you have to select such a number, both the numbers should be divisible. It should divide both the given numbers. So as these two are even numbers, I can take 2 table, because 2 can divide any even number. 2 18s are 36 and 2 27s are 54. But when you see here 18 and 27, you cannot divide with 2. 18 you may get in 2 table, but 27 you will not get. So let us try with 3 table. 3 6 are 18 and 3 9s are 27. Very good. Go ahead with 3 table. 3 6 are 18 and 3 9s are 27. Now when you look at 6 and 9, these both you can divide with 3 table. So take 3 table, 3 2s are and 3 3s are. Now you stop it, because 2 and 3 you are not going to get in a single table other than 1. So when you are finding the HCF with the short division method, you have to remember both the numbers you should get in a single table, whichever table you are selecting. So that has to be in the mind. So what is HCF now? 2 into 3 into 3. 2 3s are 6, 6 3s are 18. The moment where you are not getting both the numbers in a single table, there in that step itself you can stop it and you can conclude this is going to be the HCF. Let us try with one more example, which is 30 and 40. As the short division method is so simple, we will go with short division method. How to find HCF of 30 and 40 by short division method? By looking at these we can come to one conclusion, that these two are even numbers. All even numbers you will get in 2 table. So definitely you can select 2 table. 2 15s are 30 and 2 20s are 40. Now when you look at this 15 and 20, 15 is an odd number and 20 is an even number. So no chance of getting in 2 table. Let us try with the 3 table. 3 table we will get 15, but we will not get 20. Now go with 5 table. 5 table you can divide 15 and 20. So take 5 table. 5 3s are 15, 5 4s are 20. When you see here 3 and 4, we will not get in single table other than 1. So at this point you can stop dividing. Now you can write what is HCF. What is HCF? Multiply 2 into 5, which is 10. This is called the HCF of 30 and 40. So highest common factor for 30 and 40 is only 10. whereas in the previous sessions we have done by writing the listing all the factors of the given numbers. When you follow that method also, your answer is not going to change. You will get only 10 as the highest common factor. So in the further sessions we will come to know more and more about how to implement this HCF and LCM in the short division method. So next session we are going to meet with an interesting topic. So please wait for the session. We'll meet in the next session. I hope you all will practice. If you have any doubts, you can leave in the comment section. Thank you.